Jayant bought a certain number of white shirts at the rate of rupees 1000 per piece and a certain number of blue shirts at the rate of rupees 1125 per piece. For each shirt, he then set a fixed market price which was 25% higher than the average cost of all the shirts. He sold all the shirts at a discount of 10% and made a total profit of rupees 51,000. If he bought both colors of shirts, then the maximum possible total number of shirts that he could have bought is how many? So quite simple. The total cost price is 1000 into number of white shirts W plus 1125 into number of blue shirts B. The average cost price per shirt will be total cost 1000 W plus 1125 B divided by W plus B. The average market price per shirt. The average mark price per shirt will be 1000 W plus 1125 B by W plus B into 1.25, as these are marked 25% higher. But the average selling price is at a 10% discount. So the average selling price per shirt will be 1000 W plus 1125 B by W plus B into 1.25 for the mark price and into 0.9 for the discount of 10% on mark price. Now total selling price will be the average selling price into W plus B. So that gives us 1000 W plus 1125 B into 1.25 into 0.9. Now the profit is given as 51,000, that is the selling price minus cost price, and selling price we know is 1000 W plus 1125 B into 1.25 into 0.9, and the cost price is 1000 W plus 1125 B. So by cross multiplying and transposing we get 8W plus 9B equal to 3264. Now in this question we must understand one thing, that W and B have to be integers or whole numbers, as these are number of shirts. As we have done many times before, we'll have to check empirically, taking the value of W or B as 1, 2, 3, 4 and find. Suppose we take W as 1, then we have to check whether B is coming whole number or not, then W as 2 whether B is coming whole number or not, and so on. So once we get a value of W and B which are integers, then we know that W has to go up by 9 and B has to go down by 8 to get a whole number of values. So W plus B will be maximum when we maximize the variable with the least coefficient. So if we have to maximize W, because we'll try to buy more of the W and less of the B, because W is multiplied by 8. Least possible value of B cannot be 0, as at least one shirt has to be bought. So when we try empirically, we get, when B equal to 8, we get the value of W as 399. So that will be the number of blue shirts will be 8 and number of white shirts will be 399, and total number of shirts will be 407.